undefined variable above. And again, the pointer is the API version is a unsigned integer, 32-bit pointer, and this will give us the max supported version. Sorry, the max supported version. And if we want to decode this, we can do it ourselves, of course, using like bit operators. But we have again macros for this, like VK version major does give us the major version, basically takes shifts probably this all the way back, and the same for minor, patch, and the variant, which I think is part of the more recent API. So basically, again, VK application info. This is, we have no extensions, at least I didn't found any in 1.3. P application name, application version, P engine name, engine version, all optional. Only the API version has to be filled in this structure. And here we pass a pointer. Basically, this function, this structure, we can predefine it or define it at the function call create instance. Or I mean the create instance info. So next is the layers. Again, this is an array because we have a count and then we have a pointer. And as I marked, this is an array of layer names that we want to use. And maybe it's appropriate to mention what the layers are. Layers are mainly for debugging, or yeah, mainly debugging related. They provide logging, tracing, validation, and we can retrieve a list of supported layers on our GPU via this function. But I think first I want you to show you this kind of drawing I did. Basically, according to what it is explained in the documentation, the validation layers are inserted between the host calls, basically our function calls, the Vulkan driver, and the Vulkan driver. Basically, when the host sends API calls, before they are even sent to the driver, they are checked for valid use and valid arguments by the validation layers, and if there's something wrong there, it gives us an error. And also, when we send calls and everything is valid, but the GPU gives us an error, it gives us information back to the validation layer. And if any errors arise on the GPU from the API calls, the errors are sent back to the validation layers, and we can print it on our host call. So going back to how do we get these layers, or at least how do we get a list of layers that we can select from if we don't already know. We call this function VK enumerate instance layer properties. I think I mentioned that enumerate type functions have basically gets us information from the driver. So this is the pattern we usually follow with enumerate functions. Basically, we create a variable count. We call the enumerate function with a pointer to this variable and a null pointer to in the array part. Again, this output is basically this array pointer. It's basically a pointer to, let's say in this case, VK layer properties. It's of this type. So we call the function with pointer to the count. VK enumerate updates the count. Count gets updated with the number of available objects. Then we create an array of this type, of the required type, and we call enumerate again we pass the count, and now we have the array, and the array gets populated with the available objects. Basically, the idea is that we can create objects on the stack or on the heap with the correct size without kind of because if we pass an array that is too small, we won't get all the possible in this case layers, or if it's actually if it's too small and the count is too small, we won't get the correct number of layers in our case, or objects. And if it's, of course, if we say, oh, it's too big, it will probably cause some memory issues. So these enumerate functions gives us, once we do this kind of ritual of filling in the array, will give us an array of whatever type. In this case, it's layer properties because it's in the name. And in this structure, the first actually field is a pointer to a string or a new terminated string. So we have the layer name, the spec version. Basically, this is a version number of compatible Vulkan version. So which version the layer supports, which version of Vulkan, and the version of the actual layer is in the implementation version. And description is basically kind of a short description of the layer itself. And here I've marked that after we get this list of supported layers, from it we have to create another list or another array of layer names that we'll use and that are supported. Basically, here we have to pass list of layer names that are supported. And in order to do that, we first have to get the list from here, and from it we have to select only the layer names, or store only the strings or layer names that we will use. Now we move to the last bit, which is related to extensions. And again, this is an array of extension names. Just like the layers, we have to make an array of layer names. In this case, extension names. Again, these are strings that we want to enable. Basically, these have to be supported, so we have to get it using kind of the same principle. But let's see what I've written about extensions. Basically, extensions extend the core functionality by adding features, functions, structs, and enums. Just like layers, they are divided into instance and device extensions. I haven't mentioned this, but in previous versions, I think prior to 1.2, I think, layer name, layers were on the instance. Basically, you can enable layers at the instance level and on the device creation, the logical device. But after some version, these were deprecated, so we can ignore those and just enable. I think now everything is enabled at instance level, but the device can have its own extensions separate from the instance extensions. So, and to check support for the extensions, again, following this this logic with the enumerate here, we call a vk enumerate instance extension properties, and we get an array of, again, this structure, extension properties. And again, this is smaller than the layer properties, so not much to talk about there. The extension name is basically a new terminated string of the extension name, and the supported version following this, like the layers on which Vulkan API version it supports. Again, actually not again, but this is like really important, and it ties back to when we said that the Vulkan instance loads the API at some address. It's basically, this is why when enabled, the extension does not provide the function declarations. Thus the API does not know of them, and we have to retrieve those functions or the functions pointer via the vk get instance proc at the basically procedure address, I think it's short for, and it takes two inputs, the instance and the function name, and this returns a pfn, basically a pointer to a function. vk void function basically returns a void function. So an example of getting the address of an extension function is basically we declare the function type, which is in this case it's pfn vk create instance, and we call the function whatever we want, but usually people use the vk, basically the actual name of the function. Then we cast to that function, because again this vk get instance proc address returns a void pointer, so we have to cast it to our type, which is here. This is the function above which we had here, and we pass the instance here and the name of the function. And in this particular case, when we actually we want to create the instance, but the function itself is asking us for the instance, we can pass the no pointer. And this is because in versions prior to 1.0, all functions, even the core functions like create instance, like the main thing that loads the driver or the API, is required to have their function pointer retrieved. In versions post 1.0, basically the more modern one, these are retrieved by the Vulkan header we import and in our project. And there are even extension functions which are predefined for extensions that are commonly used or candidates to be part of the Vulkan core. Basically the Vulkan header, if you actually looked at it, it has this line down for all of the core functions and many of the extensions which are commonly used and those that are candidates to be part of the Vulkan core. So yeah, this does it. The header file does it for us, so we don't have to do it. But some more basically extensions that are not commonly used, or maybe they won't be soon candidates of the Vulkan core, we have to do this procedure. And here I've just quickly marked like the two of the most commonly used extensions, which is the surface, which we'll look at in a bit, I mean in the next part. And basically we have to enable or pass these names to our extension array, extension name array, which is the khr surface, and another one which is the khr and whatever OS you have. In this case it's Windows _ surface. This enables presenting to the screen and debug utils. Basically, as I said, actually I haven't mentioned this, but the debug report is deprecated post Vulkan 1.0, so we always have to use the debug utils, which are more well designed, I think, and this enables debugging and reporting of bugs and errors. And this is the end of the instance part. Next, I think we'll look at debug utils. So thank you for stopping by, watching. Goodbye.